Hey families, how you guys doing? Mr. Dennery here, aka the Math Master, here to help you with your children's homework and the math content that they will be learning this year in fourth grade. So we're gonna start off. We're gonna jump right into it with adding fractions with unlike denominators. All right. So you see, we have here 1/4 plus 5/12. All right. We're gonna start off with different denominators like this, and then we're gonna go into adding tenths and hundredths because they're going to see that heavy in fourth grade. Plus, that also leads them into decimals. So, starting with this 1/4 plus 5/12. One thing I like to teach the kids is first thing you have to do is look at your denominators. You see that you have 1/4, you see you have fourths, and you have 12s. Those are two different denominators, and we cannot add. Also, what kids need to realize is the relationship these denominators share. So, what they need to know is that 12 is a multiple of 4, and 4 is a factor of 12. All right, so they need to know that these denominators are multiples and factors of each other. But I like to teach the kids absolutes. So, an absolute, it means that something that's going to guarantee to work 100% of the time, not 99%, but 100% of the time. So, for example, you need to get the denominators to be the same. So, we either need to make it a fourth or a 12th. We can make it a fourth or a 12th. You can divide 12 by 3, and that'll give you 4. You can do that, but you can't divide 5 by 3 to get a whole number or I guess a factor of 5 by 3 because there's no 5 is not a multiple of 3. So that's not an absolute to always use division to go down to this 4. So what I teach kids is that the denominators are not the same, and look to your smallest number denominator because the pieces of this denominator is bigger than the pieces of this 12. So they have to kind of see that the pieces of a fourth is bigger than the 12. So if I were to draw a 12th right now, or if my box looks, crazy, that's 4 pieces, 8, 12. All right. So we have 12 pieces, we have 4 pieces. Look at this one size of a fourth. Look at this one size of a 12. You see that? This piece has more space than this piece. Because of that, now this is where the absolute comes in. Because of that, your smaller number denominator, you can always decompose it or multiply it to get to the bigger number denominator. In this case, you can always multiply this fourth to get to a 12. So we'll multiply this fourth times what times 4 will give me 12? I know it's 3. Whatever I do to my numerator, I got to do to my denominator. I got to do the same thing to my numerator. So 3/3. And how that looks like is I'm going to cut this 1/4 into thirds. This is technically a half. This is a third. So now when I do 3 times 1, that equals 3. 3 times 4, that equals 12. Now I have the same denominators, and I'm going to rewrite that equation. 3/12 plus 5/12 equals 8/12. And that's our answer. And if you look at 8/12, we can actually simplify this again down because simplifying means we can bring it down to its smaller pieces. If we divide this 8/12 by 4, you divide it by 4/4. 8 divided by 4 is 2. 12 divided by 4 is 3. Also equals 2/3. So our answer is either 8/12 or 2/3. We're going to do another one so we can kind of get acclimated to that system. We're going to go through the thinking steps. This time I'm not going to draw the model. I just wanted to visually see the absolute of why we're going to always multiply that smaller number denominator. So let's come up with a quick one in my head. I'm going to do 2/6 plus, again, let's go with let's do 12th again. Let's 12th might be the lucky number for today. Let's do a 7/12. All right. First thing you want to make sure you ask your kid, can we add these two denominators? Nope, they're not the same. Next, you got to identify the smaller number denominator, because the smaller the denominator, the bigger the piece. 6 is smaller than 12s. So now what I do with my 12s, with my 6, I'm going to multiply to get it to a 12. So now I'm going to multiply. What times 6 will give me 12 is 2. Whatever I do to that denominator, I must do to the numerator, because I'm finding an equivalent fraction. So 2 times 2, 4, 2 times 6, 12. Now that I have my denominators the same, we rewrite the expression or equation. And now we can add. Kids must know, don't touch those denominators. 4 plus 7, 11. 12 stays the same. And that's our answer, 11/12. Now we're going to jump in and we're going to apply the same. Now we're going to jump in and we're going to apply the same thinking to tenths and hundredths, because that's something that they would see. So actually on the side here, I'm going to write equivalent fractions that they just need to know. I'm going to show the thinking jobs too as well. So we know 1/10 is equal to 10/100. 2/10 is equal to 20 100. 3/10 is equal to 30 100. 4/10, 4/10 is equal to 40 100. 5/10 is equal to 50 100. 6/10 is equal to 60 100. 7/10, I may run out of space, is equal to 70 100. 8/10 is equal to 80 100. Hopefully, let's squeeze it down here. 9/10 is equal to 90 100. And then 10/10 is equal to 100, which is also equal to 1 whole. All right. I'll write this down so kids must know the equivalent fraction, because all of these tenths are getting multiplied by 10/10. I'm going to show that equation too. So for example, let's go with 3/10 plus 7 100. Again, this is that example where I say that we go with the absolute, right? Because in certain cases, I could turn 100th back into a tenth, but this case I can't, because if I divide 100 by 10, that'll give me a tenth, but I can't divide 7 by 10. All right, so I'm going to show you that real quick, what I mean by that. 100 divided by 10, that equals 10. I got them to the same denominator. But oh my God, I can't divide this and this. Nope, can't do it. Again, this is why we go with that absolute. Why we must always multiply the smaller number denominator, because that smaller number denominator has a lot of space that we can cut up, slice up, chop up, dice it up, or whatever we can do, decompose out. I like to use the mathematical term of decompose it, partition it into tenths. So this 3/10, we're going to multiply it by 10/10. This 3/10 times 10/10 equals 30/10. Parents, to make your scholars move quicker, these are kind of equivalent fraction fast facts that they must know, all right? They must know this. The quicker that they can do this, the quicker they can get to this step, all right? So now you have 30/100 plus 7/100, right? We know not to touch our denominators. We don't add the denominators because they're the same units. We're not adding them. 30 plus 7 gives you 37/100. All right. Kids should have their place value chart, but I'm going to show you the place value chart too, because again, we'll be working with decimals. So we'll make a decimal place value chart where we do one, the ones place, which also stands for one whole, or because it's a whole, ones, tens, hundreds, they're wholes. You make your decimal point, you make your tenths, and this is what I like to do. You either can write it out, but I always have the kids always do this. On top of it, you put the denominator 10 because that's tenths and 0.1. Then on the side right here, you're going to do the same thing. H is for the hundredths. Make sure they say hundredths because this hundredths and hundreds are different, right? And then we do 100 denominator slash 0.01. You see that? 0.01. All right. So now they know. So now we have 37 hundredths. All right. 37 hundredths. When we did this equation, notice that we had 3/10. So you're going to put 0.3 and you had 700. All right. So when they have to turn into a decimal, have them use this place value chart right here. We're going to do one more of adding tenths and hundredths together. All right. Cool. So now let's go. Let's go with a decent number. Let's go with 2/10 plus, let's go with 77 hundredths. Again, first thing you must pull out. Can we add these fractions? No, we cannot. Denominators are not the same. So we got to turn these tenths into 100. So we're going to multiply it times 10 tenths. All right. 2 times 10, 20. 10 times 10, 100. Plus, we got to rewrite this equation. I always have kids rewrite the equation. Automatically, no denominator stays the same. You do not add that. 20 plus 77 equals 97 hundredths. And if we write that as a decimal, that's going to give us 0.97. All right. We're able to run through 4 problems today with adding fractions with different denominators, 2 with the tenths and the hundredths. All right. Let's do one more just in case so we're safe with tenths and hundredths. Right. And that's how I'm going to do one that is going to give us over one whole. Okay. So let's go with 26 100ths plus. Guys, ready for this one? What's gonna give me over it? 8/10. All right. This time we know they're not the same. This time is on this side. Doesn't matter. We still do that math of multiplying to get this tenth to become 100 because we need the same units. That equals 80 hundredths. Rewrite 26 hundredths plus 80 hundredths. So again, denominators weren't the same. Always want to pull that out. That's the first thing you want to do. Make sure that the denominators are the same before you add. If they're not the same, you need to have this equation right here with their answer. Step 2, rewrite it. Step 3, now let's add it. We add these two together. We know the denominators don't change. That's 126 plus 80. That gives us 106 hundredths. Now, if I want to turn this into a decimal, that's going to give me, with my whole in my decimal chart, tenths, denominator 0.1, hundredths, Denominator 100, 0.01. If you ask him why I did on the top here and not on the top there, I don't want it to run into the equation up there. So we have 106 hundredths. So we know we have an improper fraction. That means it's greater than one whole. So we know if we were to turn this into a mixed number, we have one whole and 6 hundredths. Now that we turn this into a mixed number, because we have one whole and 6 hundredths left, now we put it in our decimal place value chart. I always tell the kids start off with this one first, because that's one whole. That one whole goes in the ones place, decimal point. Kids may get tripped up here because it says 6 hundredths, right? If they follow the chart, it says 6 hundredths, 6 hundredths. I'm going to put the 6 here. And they're going to be like, well, there's nothing here because you have no tenths. So you put a 0 right there. And as a decimal, it comes out to 1.06 or 1 and 6 hundredths. Again, thank you guys for watching this video. If you made it entirely to the end, use this video to assist your kids with the homework. The problems may get harder, but the thinking steps are still the same. Thank you guys again. There's going to be more videos in the future. Stay tuned.